All right, asymptotes. We are used to seeing rational functions in fraction form, but these can also appear in what's called quotient remainder form. And if you had me for Algebra 2, you had to change fractional form into quotient remainder form. We will start out with both forms in a review of Algebra 2, where we will only talk about horizontal and vertical asymptotes. But on the worksheet that you're going to be doing, we're only going to be doing vertical and slant asymptotes. So first off, this particular fraction, if I wrote it in quotient remainder form, would look like this. The vertical asymptote's always what makes the denominator 0. And the quotient, not the remainder, just the quotient, is always going to be your horizontal or slant asymptotes. Okay? So all of ours will be a horizontal asymptote at this point. Note, these are equations. You don't tell me the vertical asymptote's -6 and the horizontal asymptote is 0. Don't be a gobble turkey. That's unacceptable. They're equations. Now for the next one, this is the rational form. This is quotient remainder form. What makes the denominator 0? 4. So the vertical asymptote is x equals 4. What's the quotient? 2. So the horizontal asymptote's y equals 2. And then we have another one that I wrote in rational form and quotient remainder form. Notice this will be x squared equals -3, x equals plus or minus square root 3i, no real. There is no vertical asymptote because you can't have a square equal a negative because we're just doing real numbers. And the quotient is -2, so the horizontal asymptote's -2. All right. So now we're going to consider slant or oblique asymptotes in both forms. Note, slant asymptotes only occur when the degree of the numerator is 1 more than the degree of the denominator. Okay. Now remember, you can either have a horizontal or a slant asymptote or neither, but you cannot have a horizontal and a slant asymptote in the same rational function. Now I could give you a piecewise function where we could do that, but we're not going to, so chill. So the first case right here is where I'm going to just show you these will all be slant asymptotes. So here is fractional form, and here is quotient remainder form. What makes the denominator 0? So I have x equals 0 for a vertical. What's the quotient? X. So the slant asymptotes y equals x. Over here, the next ones, I show you in the rational form and then in quotient remainder form. What makes the denominator 0 for both? -2. So x equals -2 is the vertical asymptote. The quotient, 5x minus 1. So the slant asymptote is y equals 5x minus 1. Again, rational form, quotient remainder form. Nothing makes that equal to 0 except an I, guys, so there is no vertical asymptote. The slant asymptote is the quotient, y equals -2x. And one last one. Here is the rational form, quotient remainder form. Oh, wow. X squared equals 4 means x is plus or minus 2 is the vertical asymptote. The quotient, -3x plus 1. And so we end up with the slant asymptote, y equals -3x plus 1. Now, the worksheet that you're about to do will have questions. It'll start out in quotient remainder form. We're going to need to write all of these in quotient remainder form because they all deal with slant asymptotes. We're going to use Mr. Monomial at the bottom of the page, and on side 2, we're going to be using synthetic division, also long division. I forgot to write that in there, and to get problems into quotient remainder form. All right, examples for 1 to 6. Already written in quotient remainder form. You want to put it in rational form and tell me, oh, the numerator is x squared minus 4. I see it's 1 more than the denominator of x. Go for it. But the vertical asymptote, what makes the denominator 0 is 0, so x equals 0. The quotient we already see is x. And so the slant asymptotes y equals x. Second example, quotient 3/5 x minus 2. So slant asymptote y equals 3/5 x minus 2. Looking at the remainder, there's where I see the denominator. What makes it 0 when x is equal to plus or minus 3? So x equals plus or minus 3 is going to be our two vertical asymptotes. Next one's already in quotient remainder form. The quotient, -1/2 x. So the slant asymptote, y equals -1/2 x. I come up over here, I look at my denominator. Wow, only an I guy will make it 0, so there's no vertical asymptote. At the bottom of the page, you're going to do 7 to 12, or what I call meet Mr. Monomial, or m cubed. And you're going to go back, yes, to Algebra 1, and you say, hello, x squared, hello, -2x, and hello, 1. And then you reduce, and now you're in quotient remainder form. What makes the denominator 0 for all of these monomials in the denominator when there's a variable is going to be x equals 0. What's the quotient? Y equals x minus 2. Again, when I have a monomial in the denominator, and there's the variable, the vertical asymptote's always going to be 0, but 3x says, hello, everybody. Nice to meet you, 9x squared. Nice to meet you, -4x. Nice to meet you, number 7. And then I go through reducing, and I have 3x minus 4/3 plus 7 over 3x. So the vertical asymptote is x equals 0, as will always be true. And the slant asymptote is y is equal to 3x minus 4/3. One more of these. When I go through and say 2x squared, hello, -4x cubed, hello, 3x squared, hello, 1. And we do the reducing and get -2x plus 3/2 plus 1 over 2x squared. Again, what makes the denominator 0 is 0, so the vertical asymptote is x equals 0, and the quotient without the remainder is the slant asymptote, y equals -2x plus 3/2. Now, the next example, I'm going to show it two ways, and for those of you that have me, are used to missing the bear next to the clock, and you know he's going to tell you, does it look like he cares? And the answer is no, as he sits there in his folding chair on the beach, sipping his nice lemonade and wanting to do nothing. So when I look at this one, I can say 3x squared, hello, to all four terms. And I do my division. And notice it doesn't matter which one I go to, x equals 0. And my quotient is -2/3 x minus 4/3. And so I have x equals 0 and y equals the quotient. Now, some people say the minute you realize that the degree of the numerator is less than the denominator, there's no sense going any further because all we're looking for is the quotient. We don't care about the remainder. So you could divide the first two because the degrees are higher or equal and get the quotient and just leave all the rest of the riffraff over there. Doesn't matter. Nobody cares. What makes the denominator 0? X equals 0. What's the quotient? Y is equal to -2/3 x minus 4/3. Okay. Examples 13 through 18, 13 through 16 are synthetic division. 17 and 18 are long division. I start out with the gotchas. Y equals 2x squared over x plus 3, but wow, we're missing some terms. 2x squared needs to count down to the degree 2, degree 1, degree 0, 2, 1 blast off, so I have to put in my zeros. What makes the denominator 0 is -3. And so -3 is my divisor. Bring down the 2. -3 times 2 is -6. Add. -3 times -6 is 18. Add. Notice I've boxed off the remainder. So I know my quotient is y equals 2x minus 6. And the remainder is placed over the original denominator. So plus 18 over x plus 3. What makes the denominator 0? We already know, we used it. X equals -3. What's the quotient? Y equals 2x minus 3. One more with missing terms. I have the second degree, the first degree, but I'm missing the 0 degree. So again, I set up my table. I need 6, -2, 0. What makes the denominator 0 is 3. I bring down the first term. 3 times 6 is 18, add. 3 times 16 is 48, add. I can see my quotient is y equals 6x plus 16. And the remainder is plus 48 over x minus 3. What's my vertical asymptote? X equals 3. And what's my slant asymptote? Y equals 6x plus 16. And now off to our scenic tour to the dining room to finish up, past the stairs, see the chairs, all the garbage all over the place, all my claws, all my markers. Okay. We're going to do one without any missing terms. And so everything's ready to go. This is where many of you would have loved me to start, but I like to start with weird. And so I just put in the missing terms. What makes it 0? -2. Bring down the -7. -2 times -7, 14. Add 12. -2 times 12, -24. Add -23. So my quotient, y equals -7x plus 12 plus -23 over x plus 2. So the vertical asymptote is x equals -2, and the slant asymptote is y equals -6x. -7x plus 12. Now, sadly, we are ready for long division. And in long division, it's just painful. You set it all up. What's missing? What does 3x need to turn into a 6x squared is a 2x. Now, what do I have to do with that 2x? I had to distribute it times both terms. So I got 6x squared minus 2x. But after we divide, we multiply, we subtract, which in math means negate. So I negate my signs. The 6x squareds disappear, the 2x disappears, and the 5 comes down. So my quotient is 2x, my remainder is 5. So my vertical asymptote, what makes the denominator 0, is x equals 1/3. What's my quotient? My slant asymptote's y equals 2x. Okay, so we'll do another one. So I went and I set it up. And so what do I have to do? I have to say what's missing. I needed a -x. So I distribute, and I get -4x squared plus x, and now I subtract, which means negate. And this is 0, this is -3x, bring down the 5, start over. 4x goes into 3x how many times? Really what you're saying is that you have 4x is being divided by, I actually wrote that backwards. Can't believe I did that. Sometimes in life. I want to know how many times it goes in there, so I'm asking about -3x over 4x, which is -3/4. And now when I multiply this times both of those, I get -3x. And then over here, when I multiply this, this is now going to be +3/4. And so then I'm ready to subtract. So I change my signs. And now this will be 20 minus 3 is 17 over 4. So this is -3/4. This is 17. And this is going to be 3/4. And so we have that our vertical asymptote is x equals 1/4, and our slant or oblique asymptote is y equals -x minus 3/4. Okay, Your last ones that you have on your worksheet's going to be similar to this stupid thing here. Don't believe I wrote it upside down. But what I want you to know is the key when you get a fraction answer. This is the numerator and this is always the denominator, because this is what you're dividing by, and what you divide by is the denominator. And I just wrote it upside down when I was writing it. My apologies. Okay, have fun with the worksheet.